My name is Flash Isaac, and I'm a teacher from the future. Hello, my name is Flash Isaac, and I am a teacher from the future. Today, I am back in the present to take you through the study of mathematics. And this is episode number 1 of the series I titled 120 Days to Jamb Mathematics. It is basically 120 videos to cover everything you need to know about mathematics, irrespective of any year you are writing Jamb. It covers the past, the current, and the future Jamb syllabus. This introduction or background you are about to learn covers intro to mathematics itself, basic mathematical operations, place values, decimal places, significant figures, and percentage errors. Ladies and gentlemen, mathematics is a historic subject. Mathematics is an interesting subject, and it has been explored by various mathematicians around the world or all over the world. Mathematics is as old as humans itself. Mathematics started from when men began to understand the concept of counting, the concept of shapes. From the time where the father of mathematics, Archimedes, in the BCs, looked at surface area and volume. Archimedes is referred to as the father of mathematics. And the study of this mathematics we see today began as early as the 16th century by the Pythagoreans. That was when the study of mathematics itself began. And looking at mathematics, the word mathematics is coined from the Greek word mathema, which means to study, to learn, or the concept of exploring information. Mathematics is one of the most important subjects in the world. It is the study of numbers, shapes, data, measurements, and logical studies. Mathematics concerns itself with the affair of numbers, shapes, data, measurements, and logical studies. So, to understand mathematics properly, you need to understand the numbers, you need to understand the shapes, you need to understand data, measurement, and logical studies. Logic simply referred to as the study of that which counts as sound reasoning. When you are dealing with mathematics, you can't separate it totally from philosophy, because philosophy is as well one of the early subjects, one of the early exploration by humankind. Remember, at birth, man is a tabula rasa, meaning you are blank, you don't know much. So with time, you begin to gain, you begin to learn, and you begin to have experience. So things begin to fill your mind. You work with experience. You are no longer a tabula rasa. So it was like that in the early ages. Then men began to ask the question, which is, Esqua constitutor materi modus. What is the stuff that this universe is made up of? We came to the universe, we are living. So what is actually the stuff that this universe is made up? We see certain philosophers like Heraclitus, they began to give their own account. Then you see people later like Socrates, people like Plato, people like Aristotle, Democritus, Pythagoras. They began to give their various views when it comes to life, philosophy, and wisdom. Because philosophy is from the word philo and sophia, which is etymologically the love of wisdom. So mathematics covers logical study as well as the study of numbers, Talking about numbers, you can say if you have 1, 2, 3, 4, 1 million, all these are numbers. In the accounting world, you say the government budget is $60 billion. The government of the United States spent 50 trillion last year to cater for some things, and that was our budget. Chinese government spent 100 trillion. So when you begin to hear numbers and figures, values, that is mathematics. Then shapes. I can say that this is a rectangular figure. This board is rectangular. That is shape. If I do something like this is a triangle, a three-sided shape. Something like this, if drawn accurately, is a circle. So there are a lot of shapes in this life. When you study them, then they are part of mathematics. How about data? Data are facts. They have not been processed. They are facts. If I say that the population of Nigeria is 50 billion, I'm giving an example that is not accuracy, we are dealing with data. If I say Apple sold 5 million phones today, these are data. The rate of spread of malaria is this. So all these are facts you bring together. So by the time you begin to process all those facts or bring them together to begin to make sense, then you are dealing with information. So data, they are building blocks of information. For example, your computer, as you begin to type, I am, okay, fine, type. All these inputs going into computer, they are data. Remember, computer are devices, or you can say electronic devices, that are capable of accepting data. Then they process this data and bring out the results as output. In engineering, we have electrical and electronic engineering. Electronic engineering, they deal with appliances that accept low voltage, low power, low voltage appliances like your DVD player, your computer, your TV. These are electronics, and they hardly make use of the current from your wall socket. They are being converted from that alternating current to direct current because these devices, they don't need much power. Your phone, that is an electronic device. Your sound system at home. But devices like air conditioner, refrigerator, fans, all these are electrical devices. They use more power. They utilize AC. So ladies and gentlemen, when you go into the study of measurements, like, okay, this land is 100 by 100, or the land is 50 square meter, you are beginning to take measurements. Then you are also studying mathematics. You can see that there are a lot of things happening in mathematics, and there are a lot of branches of mathematics. The common ones are number and numeration, there's algebra, trigonometry, calculus, statistics, and probability. These are branches of mathematics we shall be exploring. And there are various common operations in mathematics, basic operations. We have the addition, which is plus or to add. We have the subtraction, also called minus. We have multiplication. This is times. We have division. There are other operations in mathematics, fractions, and a whole lot of that dealing with decimal. Okay, we shall introduce decimal in this. All these will be treated as time goes on. Addition simply means to add, to combine, to join. If I say 2 plus 3, it means we have 2 something already, or 2 values already. We are adding 3, we are combining it, we are building up. So 2 plus 3 is equals 5. So we have 2, we add 3, we are building up to get 5. Subtraction means to remove. If I say 3 minus 2, it means I have 3, I am removing 2. So if this is 3, let's say 1, 2, 3, subtract 2, remove 2, you are left with what? 1. Take a look at something. During addition, I said 2 plus 3. Why is it that subtraction, I said 3 minus 2 instead of 2 minus 3? This is because when you are subtracting a smaller number, the bigger number should come first before the smaller number to have a positive answer. If the smaller number is coming before the bigger number, you will definitely have a negative answer. In primary schools, or when you are growing up, they will tell you cannot. But at this stage, you don't have cannot as an answer. If I say 3 minus 2, this is 1. But if I say 2 minus 3, this is minus 1. So let's take this to be what you have. Let's take the negative to be what you are owing. If you have 2 and you are owing 3, and you pay the 2 you have, you will still be owing. What is left is not for you. So anytime you see a positive number, how do you know a positive number? The sign in front of it. In front of 2, we are supposed to have plus. Since there is no minus, it is plus. So any number that is standing and in front of the number there is no sign, take it as a positive number. So this is positive number. Now this 3, the number in front of it is minus. So that minus is affecting the 3. So any sign in front of the number is affecting that number directly. So this minus is affecting 3, or it's minus 3. It is not this 2 that is carrying the sign. So we'll take this positive one as what we have, the negative as what we are owing. If we have 2 and we are owing 3, after paying off, we'll still be owing. So since it is what we are owing, we'll take it as minus and not plus. So it is minus 1. Similarly, if I say 3 minus 10, this will definitely be minus 7. Because you have 3, you are owing 10. After making your payment, what is left is still owing. It's not your own. How about I say minus 2 minus 3? Minus 2 minus 3, this minus is affecting this 2. This other minus is affecting this 3. So you are owing, or you are owing. Then another minus 3, you borrowed again. So everything, no one will be your own. It will still be owing. So minus 2 minus 3 is minus 5. You are owing 2, you borrowed 3. So this will give you minus 5. How about I say minus 2 plus 3? Let's say minus 2 plus 3. Minus 2, let's take it as you are owing 2. Plus 3, let's take it as you have 3, which you paid. So if you are owing 2 and you have 3 to pay, after paying, you are left with 1. And that one that is left is your own, because it's the positive part. It's not like owing part. You have 3. What you have is more than what you are owing. So after paying, what is remaining will definitely be your own part of it, positive. So minus 2 plus 3 is equals 1, or you say plus 1. We are not adding plus to this and this because just a number already shows that it is plus or positive. Now multiplication means times. If I say 2 and this is the sign symbol times 3, what does this mean? 2 times 3 means 2 into 3 places, which means you have 2, you have 2, you have 2. So 1, 2, 3, 4, 5, 6. That is 6. 2 times 2 times 3 is the same thing as 3 times 2, which means 2 into 3 places is the same thing as 3 into 2 places. That is 6. If I say 4 times 3, it simply means 4 into 3 places, which is 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 4 times 3 is 12. So multiplication is a special kind of addition, while division is a special kind of subtraction. So the main operations are addition and subtraction. I think addition of negative number is what we refer to as, is it not subtraction or or multiplication, whatever the case is. While division, it simply means to break down. Instead of multiplication, which is to build up, if I say 6 divided by 3, this will be, you are breaking 6 down into 3. So let's say we have 1, 2, 3, 4, 5, 6. So let's break it into 3 equal parts. If we circle 2 and we circle 2 and we circle 2, you see that it has been broken down into 3. There is no remainder. So 6 divided by 3 is 2 because 2 here, 2 here, and 2 here. There are other special kinds of division like long division, fractional part of division, and decimal, which of course we will see in full as we study mathematics. So other mathematical operations are greater than. If you are saying 2 and I do something like this means 2 is greater than 1. If I add something like this on top, it means 2 is greater than or equals 1. If I say 2 times 1 and I do like this, 2, this is equal to. By the time I have this sign and I cross it like this, it becomes not equal to. So I can say 2 times 2 is like this 2. 2 times 2 is not equal to 2. That will be correct. So this is lesser than sign. So 3 is lesser than 5. 2 is greater than 1. By the time I add something like this under, it means 3 is lesser than or equals 5. So this is division, multiplication, division, subtraction, addition. There are a lot of other symbols in mathematics which will definitely encounter and play with as time goes on. No stone shall be left untouched. If I tell you, or if I ask you, this and this, which is bigger, you will definitely tell me that this is bigger than this. If I tell you that, or I ask you that, this and this, which is bigger, you are definitely going to tell me that this is bigger than this. Why is it so? Because they are standing individually, they are in a single digit. But there are times where what determines the value of a number is not the digit itself, but it is the position or the place it finds itself. Just like we said, place value. Your place determines your value. There are places where you can get a bottle water for as low as okay, let's say 50 cents or $1. Some places $5, some places $10. Internationally, let's say like Nigeria, you can get a bottle water 150 naira, some places 500 naira, some places 1000 naira, some places 5000 naira. So which means along the street it's cheaper, in clubs, in fancy restaurants it is more expensive. So the place where you find yourself determines your value. Even as an individual, where you are determines your value. If you are playing or moving around with people in the streets, or people with less value, or people with less morale, or drunkards, that will determine your value. We can't call someone like you to speak in events or to represent the country, because you need to show that you are responsible, or you are not a smoker, or you are not terrible, or you are not mad, to be able to do some representations. But if you comport yourself with decorum, you are educated, you have wisdom, you can impart something to the society, or you've equipped yourself with various skills, then your value will be bigger. For example, if I were not able to teach, or I did not learn or develop myself in mathematics, I won't be standing here teaching you. So where you find yourself, that determines your value, or your value determines where you find yourself. Anyone that comes first. Look at this. If I give you 2, 6, 9 together, and I ask you, which of this is bigger? In terms of this position, the biggest is 2, because based on its position, it is bigger than 6 and 9. We refer to this number as 269. So which means these 2 represent 100, 200. Now, this 6 represents 60 or 10, 60, right? Why this 9 is a single number? It's just a ones number. If I say 2, 6, 8, 9, I'll refer to this as 2,689. You see, 2,000. This is 1,000. This is 100. So 1,000 is definitely bigger than 100, and this is 80. This is like tens. This is a unit, a single value. So in this case, 2 is bigger than 6, 6 is bigger than 8 and 8 is bigger than 9. That is the concept of place value. The value of number based on where it finds itself. So for place value, this is the formula you should use. What the first thing that comes is decimal. Decimal point. Okay, let me just write a random number. Let me say 2, 3, 4, 8, 9 point 3, 0, 4, 5, 6. Okay, let me do it this way. If you have this set of numbers, this one here, this dot, this middle here, is referred to as decimal. 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 So, starting from decimal to this side, this should be my left. The next number after decimal, if you are moving this way, if you are moving like this, which in this case is 9, is referred to as, the place value is ones, or you call them units. That is the place value of 9. The 8th here is tens. Tens. So that is the place value of 8 in all these numbers that you have. Then the place value of 4 is 100. It's easy to do because you can just say this is 489, right? Now, the place value of this is s, add s to each of them. Thousands. Thousands. Thousand. 3,489. So by the time you add this, you simply say this is 23,000. 23,000. 23,000. So 10 is referred to two value. So now you are combining two thousands, 23, and it's still sounding thousand. So this is referred to as 10,000. 10,000. That is the place value of 2. 10,000. If we had, let's increase it to 1, 7. So the place value of this 7 will be 100,000. 100,000. The place value of this will simply be million, because 1, 2, 3, 1, 2, 3. So million will have 6 digits in front. So this is millions. Millions. So the numbers are not what matter. It is the position. So whether you change all these numbers, each of these positions will remain the same. Any number that finds itself here will become the millions. The one that finds itself here will become the 100,000s. The one that finds itself here will become 10,000s. The one that finds itself here will be thousands. So if I remove this 7 and I say 5, 5. Whether the 5 and 5 are similar, it does not matter. The position is what matters. So the position of this remains millions. The position of this remains 100. So if you have any number, if I tell you 23.01 or 23.012, this is in ones and this is in tens. That is the place value. How about towards the right of the decimal point? So here we call this tenths, which is almost, okay, this one starts with ones, but this other one, there is no ones, it starts with tenths. And in this tenth, it's not NS, no, it is THS. So why this is TENS, this is TENTHS. And after the tenth, you have hundreds. Not your 100, but 100 with THS. So this is hundreds. Hundreds. This is thousand. Thousand. This is 10,000. So just the way they are towards this side, the difference is add DTHS or THS. So this is 10,000. So as you go further, it becomes 100,000, millions, millions. So that is basically place value. The value of any number is their position. So if you are giving any number, whether with decimal or without decimal, the value is what you count. So if I give you 299, this is ones, this is tens, this is hundreds. So if I give you 0.234, this is tenths, the value of 2 is tenths, the value of 3 is hundredths, the value of 4 is thousands. Ladies and gentlemen, let's look at decimal places. Now, dealing with decimals, our focus will be on approximation. What do I mean by approximation? Now, this value you are given is to 1, 2, 3, 4, 5, to 5 decimal place. Decimal place is the numbers you have after the decimal point. If I give you 2.301, this is to 3 decimal places. If I give you 23.568, this is to 3 decimal places. In fact, if I give you 24.00, this is to 2 decimal places as well. So the 0, whether they are 0 or not, does not affect their decimal places. Any number of values you have after the decimal place, that is their decimal places. So if I say round this number up to 1 decimal place, this is what you do. You write out the whole number. This is 2. You write out the dot. Any number or any decimal place I say you should round up to, count it. From here, since we are rounding to 1 decimal place, I'll just count once like this, just 1. So this is the 1 decimal place number. But before I say to 1 decimal place, it is 2.3, we'll look at the number after the decimal place we are looking at. In this case, the number is 0. So if the number after the decimal place we are looking at is lesser than 5, let's say it is 4, 3, 2, 1, and 0, we'll just take our final answer at the decimal place we've counted. But if the number after the decimal place we are looking for is 5 or greater, then we approximate, which will add 1 to what we are looking at. Example will make it clearer. In this case, to 1 decimal place is 2.3 because the number after the place we are looking at is not equals 5 or greater. For here, we write out the whole number 23 points. Since we are dealing with to 1 decimal place, it will be, we just count only once, that is 4. And I say, before we write down 4 as the answer, let's look for the number after the decimal place we are looking at, which is the number after 4. Is it 5 or greater? If yes, it is yes. This number here is 6, which means it is bigger than 4. So we approximate. It means take 1 here, add to what you are finding. We simply say this is 23.5. If we are looking for to 2 decimal places, we simply write out the whole number. Then you count twice. 1, 2. So to 2 decimal place, we are counting up to 6. 6 is the value in the second decimal place. But to approximate, we need to look for the number after the decimal place we are looking at. Is it more than 4? If yes, we approximate. So we mean we are dealing with decimal places and approximations. So we approximate this 6 to 7 because the number after it is more than 4. So everything you are seeing here, 23.468 to 2 decimal places becomes 23.47. Let's see a few more examples of decimal places. So now, let's approximate these 3 to 2 decimal places. Here, we have 0 points. We're written the whole number and the dot. Since you are looking at 2 decimal places, we count 1, 2, right? So right. So what do we notice? The number after the decimal place is more than 4. So we need to approximate. So we take 1 here and add to this. But something funny is happening in this case, which is different from what we experienced earlier. If you take 1 to put here, or you approximate this, it will become 10. So where do you put 10? And we are looking for just 2 decimal places. So you cannot have something like this, 0.6, then 1, 0. This is obviously more than 2 decimal places, and it's not really going to work. Or, pardon, it becomes 10. Look at it. Anything from here, they are not up to 1. So this is 0.695, not 0.695. Because everything here, they're not even up to 1, left alone to be in 100. So what do you do in this case? Since this one gets to 10 when you approximate, which is 10, you put down the 0, you take the 1 and add to the previous number. So this one added to 6 becomes 7. So 0.70 is 0.695 to 2 decimal places. Then let's approximate this to 2 decimal places for better understanding. It becomes 23. So the second decimal place will be 99. But the number after it is more than 4. So we approximate. So when you approximate, it means we take 1 to add to this 9. This 9 becomes 10. So like I told you in the upper one, let's put down the 0. We take 1. So that one we've taken, if we add it to this second 9, it becomes another 10, which you can also not put down. So since this second 9 has also become another 10, we put down the 0, we take the 1. So where does that one go? The one will further come forward to the whole number area to add to the next number. So this next number is 3. So that one will make it 4. So this becomes 4 to 2 decimal places. And this one, 39.000831 to 2 decimal place, we count 1, 2. The next number is 0. It is not up to 5, so we cannot approximate. So we just leave it as 39.00 at 2 decimal places. With this, I hope you are beginning to understand the concept of decimal places. Significant figures are the number of digits required to find the accuracy or precision of measurements. After taking measurements, you say, okay, how many values are important for the precision of this measurement or for accuracy of this measurement? You pick out those values and you say, okay, these are the significant figures. Now, the relevance of decimal places and significant figures is to avoid having too many values. Just imagine I say 0.25 0.0000000000000000. It gets so confusing. So we need to be coordinated. We need to round off numbers. We need to have a more precise answers to things. So as such, we need certain rules that can make measurements easier for us to manage, like approximating or rounding up to certain decimal places instead of writing everything to occupy our space or bringing out significant figures. Now, while dealing with significant figures, there are 5 major rules to follow. Please write down the rules. Rule number 1, all non-zero digits are significant. This is what I mean by all non-zero digits are significant. If I give you something like 2, 3, 4, every number here are significant. So this is basically 3 significant figures. Every non-zero digit figures are significant. Rule number 2, every number in between 2 non-zero numbers are significant, or zeros in between 2 non-zero numbers are significant. This is what I mean. If I give you 4, 0, 0, 0, 0, 2, everything becomes significant because you have a number at the beginning, a number at the end. So everything in between are significant. So this one has 1, 2, 3, 4, 5, 6. 6 significant figure. So rule number 1, all non-zero digits are significant. Rule number 2, every zeros or zeros in between 2 non-zero numbers are significant. So everything here will be taken as significant. Zeros to the right of non-zero numbers are significant only if there is a decimal point. Look at this. This is non-zero number, right? This 2, 3, 4, right? This is the 3 significant figure. Now, if you have zeros to the right of this number, like 0, 0, 0, 0, 0, 0, and 0, all these zeros are not significant. So this remains 2, 3, 4, or this remains 3 significant figures. No matter the zeros you add in the front of numbers that are not 0, those zeros are not significant. If you have 8, 0, 0, 0, 0, 0, 0, this is one significant figure, because all zeros to the front of non-zero numbers are not significant. Now, there is a case or a scenario where zeros to the front of non-zero numbers are significant. That is only when there is a decimal point. When there is a decimal point, zeros to the front of non-zero numbers, they become very, very significant. For example, if I give you 39.00, now there is a decimal point, so these two zeros become significant. Whereas 3900 is 2 significant figure, 39.00 is 4 significant figure. So if there is no decimal place, all 3 zeros to the right of non-zero digits are not significant. If there is a decimal place, they become significant. So this is 2 significant figure. Now this, because of the decimal place, it is 4 significant figures. Which means if I ask you to approximate this to one significant figure, if I ask you to approximate this to 4 significant figure, you're definitely going to stop your counting from here. If you ever to even be 1 to 4 significant figure will be 39.00. So long as there's a decimal point, everything becomes significant. Take that very serious. So we've given about 3 rules or so. Zeros in front of digits are not significant. That is number 3. Zeros in front of digits, if they're decimal point, they are significant. That is 4. Now number 5, zeros to the front of whole numbers or to the front of non-zero digits are not significant, whether there is decimal point or not. Look at this. If I give you 0.00263, all these ones are not significant. So the first non-zero number, that is where it starts counting. So these numbers, they are definitely 3 significant figure. If I give you 0.00203, this or 2034, this is to 4 significant figures. These first zeros are not important. So when you have first set of zeros, you have a number. Those first set of zeros are not significant. Something like this, 25. This is 2 significant figure. Now applying all these rules, this becomes 1 significant figure because all these zeros don't matter. This becomes 1 significant figure because all these zeros in front do not matter. Now look at this. If you have 0.0204 and every other thing in front are zeros, the first number that is not 0 is the first significant figure. Now every other number in front of it, whether they are 0 or not, they are second, third, and fourth. So this is second significant figure, and this is the third significant figure. So for 0.0000100002, this first that is not 0 is the first significant figure. Every other ones are not significant figure. So for here, this is 5 significant figures because since there is decimal, every other thing becomes significant since this is non-zero. So here is to 5 significant figure because we have non-zero number, everything makes sense. So this is just 3 significant figure. So every other thing here are non-significant. So you can approximate to whatever you want. If you're approximating this to 2 significant figures, it becomes 0.00057. This is to 3 significant figures because all these are not significant. Now there is a decimal here, so everything becomes significant. So this is 3 significant figure, this is 5 significant figure, this is to 7 significant figure because there is decimal, so all the zeros will matter. Now this is 7 significant figure as well. 1, 2, 3. Okay, this is 3 significant. Wait, if I ask you to approximate this to 3 significant figure, you will stop here. But itself, it is 6 significant figure. This is also 6 significant figure. Ladies and gentlemen, that is it for significant figures. How about percentage error? In measurements, we make errors. For example, if a length is 2 centimeter. So while I am measuring, I measure it to be 2.1 centimeter. You agree with me that I have made an error because this is the actual value. This is my measured value. So measuring instruments most times or while reading we make errors. Like for meter rule, you see parallax errors. You see a lot of zero errors. An instrument that is not starting from zero, you are making measurement and you are subtracting it from zero, or you are taking it as a measurement starting from zero. So there are a lot of errors that are possible. You simply agree with me that for here, the error is 0.1 centimeter, which is the value I measured minus the actual value. Now, while dealing with errors, we don't do negative number. Even if the measured value is lesser than the actual value, you subtract and get the absolute positive answer. If this were 2 centimeter and I was able to measure 1.8 centimeter, my error will still be 2 minus 1.8. That's let's say 0.2 if I am right. So error is measured value minus actual value. How about we are trying to put this error in percentage? In percentage error will simply be the measured value minus actual value over actual value times 100. So the value you got, you subtract it from the actual value that you are supposed to get, you divide it by the actual value you are supposed to get, and you multiply by 100. That will give you your percentage error. So for any question you are given, analyze to see the value you measured, to see the actual value, and over the actual value multiply by 100. That is your error in percentage. Ladies and gentlemen, we've been able to introduce mathematics. Now this is episode number 1. See you in episode number 2 until we get to 120 of this series. I remain Flash Isaac, your favorite teacher from the future.